You know, you see a construction site and it's this incredible hive of activity, but it's also one of the most dangerous workplaces in the world. So the big question is, are the accidents that happen there just tragic random events, or are there patterns hiding in plain sight? Well, today we're going to break down two huge studies, one from the US and another from China, to really get to the bottom of it. Okay, let's jump right in. First things first, let's talk about the human cost, because it's staggering. A decade-long study in the United States found that on an average workday, more than 3 construction workers don't come home. Think about that. 3 families, their lives changed forever, every single day. That's a number that forces you to look deeper than just the headlines. So, here's our game plan. We're going to start with a couple of classic ideas about why accidents happen, the domino effect, and a triangle of risk. Then we'll get into the hard data on what the most common accidents actually are, and this is where it gets interesting. We'll uncover some wild patterns in when they happen. And then finally, we'll tie it all together to see how these tragedies can actually be prevented.
All right, so let's start with this first concept, the accident domino effect. This is one of the oldest ways people tried to make sense of accidents in the workplace. The idea is that it's all just a simple, predictable chain reaction.
It's called Heinrich's domino theory, and believe it or not, it goes all the way back to 1936. The whole idea is super straightforward. An injury is just the last domino to fall in a line. So, if you want to stop the injury, all you have to do is pull one of the earlier dominoes out of the way. Simple, right? So, how is this supposed to work? Well, the theory says it all starts with someone's social background. That leads to some kind of personal failing or mistake, which then causes them to do something unsafe or run into a hazard. That unsafe moment is what causes the accident, and boom, the final domino is the injury. It's a very neat, straight line from A to B to C. But, is it really that simple? Is an accident just one domino knocking over the next one? Or is there something, I don't know, a little more complicated going on at a busy, chaotic construction site? And that question leads us to a much more modern idea, what we're calling a triangle of risk. This model says an accident isn't a simple line of dominoes. It's a failure inside a big, interconnected system. This is called Ferenzi's systems theory, and it's a huge shift in thinking. It totally moves away from blaming one person's mistake. Instead, it looks at the balance, or the imbalance, between 3 key components: the human worker, the machine or tool they're using, and the environment they're working in. An accident happens when that delicate harmony just breaks. So we've got these two theories. One's a simple chain, the other's a complex system. But what do these failures actually look like in the real world? Well, this is where the theory hits the pavement. The data gives us a crystal clear picture of what's known as the fatal 4. And this chart just lays it all out. As you can see, falls are in a completely different league, making up almost 44% of all accidents. That's nearly half. Then you have workers getting struck by objects, caught or in between machinery, and electrical shocks. Put them together, and these 4 things are responsible for the vast majority of tragedies on a job site. Now let's just zoom in on that number 1 killer for a second. False. We're not talking about a minor trip. When a worker falls from up high, the most likely outcome, happening 58% of the time, is a fracture, a broken bone. And the most common body part that gets injured? The head, in a full quarter of all these falls. I mean, that just shows you how absolutely devastating these events are. So knowing what happens is huge, but a really groundbreaking study out of China decided to ask a different question. They asked, when do these things happen? And what they found? Well, it's pretty remarkable. So are these accidents really just unpredictable? A terrible case of being in the wrong place at the wrong time? Well, the data says not really. Turns out there are some very clear patterns hiding in the chaos. Okay, check this out. Researchers found something they actually call the Monday effect. The data shows a huge spike in fatal accidents on the very first day of the work week. The thinking is that after a couple of days off, it's just harder for workers to get their head back in the game. Plus, new tasks often kick off on Mondays, which means new, unfamiliar risks. And the patterns get even more specific when you look at the clock. There are 2 really clear danger zones. The first peak is between 10 and 11 in the morning, right as that pre-lunch fatigue starts to set in. Then you see a little dip around lunchtime, followed by a second, even higher peak between 3 and 4 p.m. as everyone's getting worn out at the end of the day. All right,
So we have the theories, we have the types of accidents, and we even know the times they are most likely to happen. So what's the big takeaway? How does all this come together to actually save lives?
And this is really the key. It's not one domino, it's a whole system failing. It's that perfect storm of human factors, like a moment of misjudgment, environmental factors, like a slippery surface, and mechanical things, like a faulty ladder, all lining up at those predictable, high-risk times of day. Let's look at a real-world example of this system failure, pulled right from the U.S. accident reports. To get a tragic fall, you might have a poor working surface. That's your environment. You combine that with a worker's misjudgment. That's the human element. And the source of it all is the ladder. That's the machine. When those three things click into place, that harmony is gone and an accident happens.
And this is where it all becomes preventative. It stops being about finding someone to blame, and it starts being about understanding these relationships and these patterns. It's about knowing that Mondays are risky, that late afternoon is a danger zone, and that the real job is to manage the entire system, human, machine, and environment, to keep it all in balance.
And that leads us to a final, really powerful thought. The data doesn't lie. The patterns are right there, hiding in all the noise. So the question we're left with is a big one. If we can see these patterns so clearly, can we finally start to predict and ultimately prevent these dangers before they even have a chance to happen?